Welcome back to our Advanced DSA series. Today, we're diving into backtracking, a powerful algorithmic technique that helps you explore all possible solutions by navigating through decision trees. Whether it's solving puzzles, games, or combinatorial problems, backtracking is your go-to strategy. Backtracking is a methodical way of trying out different sequences of decisions until you find one that leads to a solution. It's like trying to solve a puzzle by testing every possibility. If you reach a point where no solution is possible, you backtrack to a previous step and try a different route. Decision tree. Let's consider a simple example of solving a subset sum problem where we need to find a subset of a given set of numbers that sums up to a target value. This can be done using backtracking, where we explore each possible subset, and if we find a subset that sums up to the target, we stop the search. Here's a diagram of the decision tree for the problem where we have a set of numbers 3, 34, 4, 12, 5, 2, and the target sum is 9. Each node represents a decision to include or exclude a number from the set. The left child of a node represents including the number, while the right child represents excluding the number. We continue this until we either find a subset that sums up to the target or exhaust all possibilities. A classic example of backtracking is the n-queens problem. The challenge is to place n-queens on an n-cross-n chessboard such that no two queens threaten each other. This means no two queens can share the same row, column, or diagonal. Let's look at the C++ code for n-queens problem. IsSafe function checks whether it's safe to place a queen on the board at a given row and column by ensuring no other queens are in the same row, column, or diagonal. Solve n-queens util function is the recursive function that attempts to place queens on the board one column at a time. If placing a queen leads to a solution, it returns true. If not, it backtracks by removing the queen and trying the next position. Backtracking is done when a position leads to a dead end. The algorithm removes the queen, backtracks, and tries the next possible position. Backtracking isn't just for the n-queens problem. It's a versatile technique used in various problems like Sudoku solver, maze solving, subset sum problem. Let's look at another example. Solving a Sudoku puzzle using backtracking. IsSafe Sudoku function checks if it's safe to place a number in a given cell by ensuring it doesn't conflict with existing numbers in the same row, column, or 3 by 3 subgrid. Solve Sudoku function is a recursive function that tries to fill each cell with a number. If placing a number leads to a solution, it returns true. If not, it backtracks by removing the number and trying the next one. To sum up, backtracking is a powerful algorithmic technique for exploring all possible solutions by making decisions and backtracking when you hit a dead end. It's particularly useful for solving combinatorial problems, puzzles, and games where all potential options need to be considered. That's it for backtracking. If you found this video helpful, don't forget to like, share, and subscribe for more deep dives into DSA. Have questions or suggestions? Drop them in the comments, and let's keep the learning going.